Right, 15 then, guys. Y equals cos x over x squared. So we got a quotient again. So that u is the thing on top, v is the thing underneath. So let's do our grid. Just take a moment of time on it. So du dx, cos goes to minus sine, doesn't it? And dv dx, power, 2 comes down, x to the 1 less than 2, which is 1. There we go. So dy dx then is v du dx. So I'm going to front load the minus and the x squared sine x there, and that product, minus u dv dx, and I'm going to front load the 2x before the cos x in the product, over v squared. There's an x common on top that I can take outside a bracket, yeah, and then I'll be able to divide it. So dy dx, let's take an x out and a minus, yeah, it's common, x sine x inside, minus 2 cos x, isn't it? Just double check that. There's our 2 lines. That will give us minus x squared sine x, yeah, that's fine. And the second line will give us minus, I've taken the minus out, so that'll be a plus, and there's 2x, so it's a minus 2x cos x, that's fine, all over x squared. So one of these x's will now cancel top and bottom, and we can write dy dx. So it'll be minus bracket x sine x plus 2 cos x over x. That's fine. Again, you could split that fraction up, couldn't you, into its constituent parts, but I'm going to leave it there for now. Tied it up for the most part, isn't it? Alright then, that's the derivative there. One little thing to say is that a lot of people, it's very common to see someone spot that x squared there and that x squared and just cancel them out. No problem at all. Chung chung. But maybe we could illustrate that by a simple example to show you that you can't do that. So let's have something, shall we? We'll have, say we had 3 squared times 1 minus, say, 4, alright, over 3 squared. Because if we can cross off the square there and there, then this is very similar in form, isn't it? We should be able to just cross off. So this, at the moment, this is 9 times 1 minus 4 is 5 9ths. So this is 5 9ths, isn't it, if you work it out? But if we did, suppose we were able to cross that off and leave a 1, you'd have 1 minus 4 on top, which is minus 3 over 1. But 5 9ths is not the same as minus 3 over 1 minus 3, is it? So quite clearly then, just looking at simple examples shows that you can't just, what you can't do is pick and choose. Yes, you can divide common things top and bottom, but they need to be common to the whole thing on top. Once they're common to the whole thing on top, you can pull them outside of a bracket, just like we did here. We saw there was a common thread thing on top, right through the whole line. Pull that outside of a bracket, and then you've got lots of, and then you can divide what's common top and bottom. Only in that instance, yeah, you can divide. You can't just pick and choose along a row of terms what you think you can cut out. Alright then, very common mistake, does happen a lot, so try and avoid that one. Yeah, and if ever you're unsure, just check it with some simple numbers, and you can verify whether, generally, whether some, at least false, you can check that. Okay, then let's go on to the next one, number 16. Great.